Welcome to my online math and science tutorial videos. These videos are not designed to be just lectures. In each one, I'll provide explanations of concepts, but I'll also offer opportunities for you to complete sequentially arranged problems that would lead toward mastery of the concepts. In order to participate, the minimum materials you'll need are a pencil, a calculator, and your own scrap paper. If you wish, you can print the worksheet files that I've linked to. One of the files will use the exact same problems and numbers that appear in the video. At certain points in my videos, I'll pose questions to you, and I'll stop talking for a brief time so you can find your answers on paper. If you need more time, then you can of course pause the video and hit resume when you're ready. After that, I'll answer any questions I had displayed. Now I'll begin the tutorial. Imagine yourself living in a time when people had very limited knowledge of language and mathematics. You observe a common object, a rock, and wish to describe it to another person who hasn't seen it. You can use a blank piece of paper for this and something to make symbols on the paper with. But assume that you can't use verbal language or written words, though. What is one way you could express or communicate to another person that the rock exists? I'll stop talking for a moment while you find your answer. You can, of course, pause the video if you need more time to finish, and you can hit resume when you're ready. After that, I'll give my answers. Now I'll give a few possible answers. It would have been common in some cultures to draw a picture of the rock. A hieroglyphic, perhaps. At first it might be unclear what it is I'm drawing, so I may try to render it as best I can to represent the physical qualities of the rock. Now it looks a little more rock-like. But one of the first ways that ancient cultures would have used mathematics to describe the physical world would have been by counting. And so, a simple tally mark, which is a vertical line, could represent the rock and convey that it exists. Some cultures would have counted with dots instead. Counting can be performed using hieroglyphics, tally marks, or even the decimal system we use today. Find a way to represent two rocks. Now, clearly, these rocks are not the same. They have different shapes, sizes, and colors. And if I'm drawing a picture, then I can bring out some of the physical differences between the rocks. I could convey, for example, their basic shape and relative sizes too. But if I'm using the tally system, there is no distinction between the symbols that I've drawn. Physical qualities of the rocks aren't recorded, and they're just treated as equivalent. This simple example demonstrates how math can serve as an abstract representation of the real world. But clearly, math doesn't tell the whole story. As we use more and more advanced techniques, we'll see that we can describe reality with ever-increasing detail and complexity. And the process of approximating real-world phenomena with mathematics is often called mathematical modeling. In order to count something, you may wish to establish an arbitrary criteria or definition of what it is you're looking for. Go ahead and write down what it is you believe you're looking for when deciding whether an object should be counted as a rock or not. I'll give a few examples. I believe rocks are naturally occurring, naturally formed, solid masses, and composed of minerals or mineral-like substances. So it's up to you as the person doing the counting to decide whether an object qualifies as a rock or not. Below I've pictured a pile of objects that I found in nature. Use the tally system to count each object that you believe is a rock. I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rocks. The tally system had only one symbol, the single line or hash mark. Today we don't primarily use that system though. We use the decimal system. How many different symbols are used for numbers in the decimal system? So there are 10 symbols. What are the symbols? Well, the first one is actually the hash mark. It is the number 1. But after that, humans came up with different designs to represent different numbers of objects. And eventually, the symbols 2 through 9 were added. But one symbol is missing. What is that 10th symbol? It is the number 0. I had already said that math is an abstraction of reality and doesn't tell the whole story. So what physical qualities do rocks have that might be worth mentioning? In what ways can rocks be different from each other, and how can they be similar to each other? One thing you might notice is their shapes, their sizes. Here's a science word, their volumes. Rocks could differ in color, texture, and hardness, and also in mineral composition. They could have different masses and different densities, and the list goes on and on. Here's a philosophical question. Does one half of a rock exist? Say I have a rock that has a crack in it. I approach the rock with a hammer and swing the hammer down, busting the rock into 2 fragments. Is each of those fragments now 1/2 of a rock? If a person stumbles across these fragments at some later time, how would they know that the original rock had been smashed by the hammer? Would they count these objects as half rocks? Or would they simply count them as rocks? I hope this situation illustrates that when it comes to the question of does half of a rock exist, I'll say no. A rock either exists or it doesn't. This concept is fundamental to counting with the natural numbers. These are the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. There's a ... at the end of the list because the list goes on forever, to infinity. The set of natural numbers is the first number set that humans used in our history to count things, so they're also often called the counting numbers. Now we can put the natural numbers into a mathematical set when we separate them with commas and surround that list with braces. The symbol reserved for this set is big N, and it represents the set of all natural numbers. Here, some natural numbers are displayed with a primitive tally system. Not only do we have more symbols today than the one that was used in the past, we now have a place value system to represent the larger and smaller numbers. In a place value system, a digit's position in a sequence gives information about that digit's value. For example, in the number 19, the position of the 1 in the sequence tells us it's worth more than 1. It's actually worth 10. Use this idea to write the first natural 15 numbers in their decimal system form. The natural numbers in the decimal system are 1, 2, 3, 4, 5, 6, 7, 8, 9. We have no higher symbol than 9, so we'll cycle back to 0. But we don't want to go down in value. We want to go up. And so we'll place a 1 to the left of the 0, signifying that that 1 is actually worth 10. And then we can continue. 10, 11, 12, 13, 14, 15, and so on. Different from a number, a unit is some physical property or concept of the universe that we're interested in counting or measuring. And the term quantity could be considered a number multiplied by a unit. For each quantity below, identify the number and the unit. The first one's done for us. So the unit here is the single diamond. That's the thing that's being repeated, and it's being repeated 5 times. On the right, we can see a depiction of what the quantity 5 diamonds really means. It's either 5 times the single diamond or 5 diamonds being added together. And now I'll give you a moment to try the rest. So in the next example, the unit that's being counted is the single rock, and there are 3 of them. We can represent the rock as a single picture and say that we're going to repeat it 3 times. And on the right, I'll represent this with an addition. Here's my answer for $1. 1 times anything is that thing. And here's my answer for 0 apples. 0 times anything is 0. When it comes to the dimensionless number 4, this represents a count, but we don't know what it is we're counting. It's unitless. But something still has to be written down in order to follow the pattern. So what should we write down? Let's write down a 1. And the 1 is being repeated 4 times. So what did you write in the final space if you truly followed the pattern above? 1 plus 1 plus 1 plus 1. At first, this exercise might seem like a child's game, but it's actually an example of an important type of reasoning that humans use to understand the world. The types are abductive reasoning, inductive reasoning, and deductive reasoning. What type do you think you used to complete the pattern? In many problem-solving processes, there may be more than one type of reasoning going on at the same time. However, observing a pattern and assuming that the pattern continues is an example of inductive reasoning. It's all about patterns.